Hello everyone and welcome to your linear algebra review on the determinants of inverse matrices. My name is Jason and I work for the ASU Tutoring Centers. Now, calculating the determinant of the inverse, just like in previous problems, in previous examples we had, there's a nice formula for it. And I'll show you what it is right now. The determinant of the inverse of a matrix is 1 over the determinant of the matrix itself. This is your fancy formula. Now, you have to be very careful here, right? Not all matrices are invertible. And in fact, we know which matrices are invertible, right? There's sort of these three different terms that we kind of throw around. So we would say a matrix, let's say A is invertible. That's the same thing as saying that your matrix A is non-singular, which you can decide if it's non-singular or invertible by showing that A has a non-zero determinant. So you want to think of all three of these concepts as working together, okay? Your matrix is invertible or non-singular. Those are pretty much the same word. If your matrix A has a non-zero determinant. Okay, so then you run into issues. Your matrix would then be not invertible or singular if it had a zero determinant. And looking at this formula, that kind of makes sense, right? If your matrix has a determinant of 0, then we run into problems. Then the quote unquote determinant of A inverse would be 1 over 0, which doesn't exist, right? You can't divide by 0. So that's sort of a way you can see that the inverse wouldn't exist if the determinant is 0. Because if the determinant is 0, then the inverse would have a non-existent determinant, which doesn't make any sense. Okay? So this is almost like a reason as to why matrices that have a 0 determinant are non-invertible, is because they wouldn't have a determinant. Okay? So this equation up here only applies for invertible matrices. So matrices with non-zero determinant. That's the only way this equation applies. In any other case, it fails, okay? Because the inverse just doesn't exist. Cool, so keeping that in mind, I'll rewrite it. Determinant of A inverse equals 1 over the determinant of A. So let's keep that in mind. So if we wanted to find the determinant of A inverse for this first part, we would first have to find the determinant of A, right? I mean, we could find A inverse. We could actually calculate what A inverse is and then find its determinant, but it's going to be a lot easier to just find the determinant of A and then use this formula up here to find its inverse if it exists. So we went over in previous videos how to do this. I'm going to review calculating the determinant of a matrix for part A. For part B, I'm not going to do that. So to calculate the determinant of A, you pick a row or column. Typically, you want to pick one that has the most amount of zeros in it. So I'm going to pick row 2. And then what you do is you go through each element of that row and or that column. Okay? And the cool thing is you can skip over the zeros because 0 times anything ends up being 0. So we can really skip over this term and we don't need that one. So we really only need to worry about the middle term. Okay? So what do? You take the middle term out, then you cover up the row and the column that term exists in, and you write out the matrix that's left over. We're left over with a 2, a 1, a -1, and a 2. And then the last step is to decide what sign you're working with, whether it's plus or whether it's minus. And how you do this, if you recall, the top left position is always going to be positive. And then it sort of alternates, right? So that's plus, then this one would be minus, this one would be plus. And then your next row is completely swapped. So this one's minus, and then plus, and then minus, and then your last row is swapped again. So if we were looking at 3 as the element that we pulled out, it would have a plus. It would be positive. So we would have a plus sign out front. Okay. So this is what the determinant ends up being, right? Because again, we don't need to worry about this term or this term because they're zeros. So we have a positive 3 times the determinant of this 2 by 2. And let's recall the determinant of a 2 by 2 is A times D minus B times C. So this ends up being 4 plus 1, which is 5. 3 times 5 is 15. So the determinant of A is 15. That means, because this is not 0, I'll sort of emphasize that our matrix A is invertible, or we could also say our matrix A is non-singular. Those mean the same thing. So because of that, we're allowed to apply this equation up here. So if we wanted to calculate the determinant of A inverse, it would be 1 over the determinant of A, so it will be 1 over 15. That's the determinant of the inverse matrix. Awesome. And then let's go ahead and calculate B. So again, I'm not going to show you the process of calculating the determinant of B because we have reviewed that earlier in this video. We just did, and we also reviewed that in previous videos. Its determinant actually ends up being 0. So because this is 0, we would say B is singular or non-invertible. So this equation actually, we can't use it. We can't use it because B inverse just doesn't exist. There is no inverse. So the determinant of B inverse does not exist either, right? Cool. That's everything I have for you then. So thank you for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. So if you want more information about the free resources we have on all 4 ASU campuses and online, please check out tutoring.asu.edu for more videos like this that go over specific concepts from your course, as well as to see the upcoming review session schedule for the exams in your course. Go ahead and check out that link below. Thank you all for watching again, and have a wonderful day.